Hey guys, hope you're doing good and welcome to Chapter 8 Physics Class 10 CBSE Material Properties of Solids. This is a revision video, so use this video only for revising this chapter, not for actually studying it. At the end of the day, in this chapter, you primarily look at material properties. There are two types of properties, elasticity and plasticity. Elasticity, at the end of the day, tells you how much a material can change its shape and regain it back. Whereas plasticity tells you the tendency of a material to not regain its shape whatsoever, right? So this is very, very important. Now, at the end of the day, in order for us to learn elasticity and plasticity, we have to learn a couple of important technical terms called as stress and strain. Now, here stress is, at the end of the day, force per unit area. This is basically the restoring force. So when you push an object, try to deform it, there is a restoring force, right? And the restoring force acting per unit area is called as stress. And when the object itself is being deformed, the amount of deformation the object undergoes, right, with respect to its original length or with respect to its original volume is called as strain. At the end of the day, for CBSE, you need to be looking at compression, shear, tension, and volume. So you have compressive stress, compressive strain, shear stress, shear strain, tensile stress, tensile strain, volumetric stress, and volumetric strain. So what is compression? Imagine that you have a steel rod like this, right? This is its original length. Now imagine I'm going to press it on both the sides, at the top and as well as the bottom. What's going to happen? Its length is going to change. Now obviously it's going to get a bit thicker, but we'll ignore that for now. So its length changes by delta L. Now remember, this is very, very important. Now let's look at tensile forces. In tensile forces, what's going to happen is you have the original body, which is here, and this time the load at the top is applied like this, and the load at the bottom is actually, sorry, the load at the top is applied like this, and load at the bottom is actually applied like this, meaning the entire rod is getting elongated. And in this case, you end up with something like this, and in this case, this is delta L, right? This is the measure of deformation. Shear is slightly different. In case of shear, what's happening is you have the rod like this, and the rod, as it is basically being bent. So the load would be acting somewhere like this, and this is the original axis of the rod, and now you can see that this is the modified axis. So in this case, there is like the deformation is almost like this angle theta. In fact, we used tan of this particular theta to basically describe strain or change in length that takes place because of shear.